Hi, so my name's Brian Meaney. I'll make you two promises. I won't mention any Cisco products. And the other thing, I will definitely reduce the amount of times that I actually refer to SDN to a bare minimum. I think, you know, it's legally compliant to mention SDN every time you do a presentation, so, you know, there's my little bit done. All jokes aside, though, I think we really need to look at where the industry is going and what people really want from SDN type concepts. And when you take out the kind of things that really are meaningful, I think the idea of centralized control in certain cases does make sense. I think we all have to accept that separating control and data plane, what's that really about? It's really about simplification. And something which the industry in general really tried to go with and really push for the last few years is this whole thing of programmability and abstraction. So I think when you look at it and you kind of go, are there good concepts? There are absolutely good concepts. How do we take those and how do we apply them to today's technology? And I think that's one of the harder things. You get a lot of theologists saying, you know, build it from scratch. That's not the way most people are. So one of the technologies which we've definitely looked at and definitely seeing, how can we enhance what we have today? So looking at it, very much what we saw was this thing called segment routing. And really this was taking it back to the basics of where MPLS begun. So what we really talked about was, how do we simplify things? How do we actually take them to the situation where, you know, we have less protocols, less flexibility? How do we take out things like RSVP? How do we take out things like LDP? How do we get more scale? But still we have to use the existing MPLS-enabled kind of technology and hardware that's in place. So basically, what we want to do is this. We want to take the concept of a flow or an application. How do we map that to segments? And then how do we map that segment to a path? A determined path, a dedicated path, a path that we know from end to end. So again, we can't lose any of the things we have today. We can't offer this and still don't have fast reroute or fast convergence. So what has basically come out of this is the capability called segment routing, which will allow us to actually do this. Keep the properties, keep the resiliency, but simplify it down. Again, if we were to look at it and look at the overall concept, what are we really talking about? It's really, and I use this term very loosely, it's kind of like source routing. Now, source routing IETF is slightly different, but it means that the source actually chooses the path you take through the network. And that's very key, because what you're really saying is, you know, you don't really keep state in the network. The state is actually in the packet itself. So what you're doing is in the actual packet header, you actually put a list of segments. Now, the word segment, to a lot of people, what is a segment? And in essence, a segment is kind of an abstract for any type of instruction. So it's simple. Go to C, you know, take this link down to D. That's really what a segment is and what the meaning of it. You know, it's an instruction on how to actually do things. So if we look at the early definition of what segment routing was about, there was two types of segments initially defined. The first was a nodal, which we refer to node later on, which is basically, it's a label allocated that is unique to each node. So it comes from a segment routing registry. It's globally significant to each node in the network. And we just take the example here for node Z. You know, it's assigned 65, label 65 has been assigned for it. Again, if you wanted default behavior, if you wanted nothing special for specific traffics, all you would have to do is put label 65 to get to Z, and it will just take the best path as is today. But at the same time, what we did is you have an adjacency label. And an adjacency label is very much about, you know, how do you have a locally significant label that will take you to an adjacent path. So for example here, if you wanted to go between C and O and you wanted traffic to go in a specific direction, we give it label 9001. So it's very simple. It's a very simple idea. Actually so simple that most people at the start said, why didn't we think of this years ago? You know, why did we reach the complexity we reached? And we got there for different reasons. But again, if you look at that basic concept, you know, very simple. And again, if we look at the actual label usage, you'll find that it's very, very similar to what you see in an existing MPLS network today. So very much, if I wanted to take a dedicated path from end to end, I wanted to go A to C, I wanted to cut down through O to P to Z. You know, how would that look? So very much what I do the nodal segment label to C, I then do the adjacency segment to O, and then I do the nodal label to Z. So again, if you look at the actual packets, what it will do is there's an explicit path. It will look at the top label. It would look at label 72. It will do the penultimate hop popping, obviously at B. Then going to node C, it would then see the 9001. It then, again, penultimate hop popping, go down to node O. And then at node P, again, seeing 65 would pop, and the packet would arrive at Z. So from a point of view of anyone looking at this, traversing through the network, it's exactly the same as an MPLS network. But most people realize there is a fundamental difference here. It's a lot more simple. It's a dedicated path, and it's from end to end. So how have we used this? A lot of people have said, well, this is an automatic thing for PAT computation. So PAT computation or PAT computation element, and the PAT computation element protocol is really about how do you, create PATs all the way through the network. Now, I would say the best use case we have is probably a modification of that. It's really about how do you take certain traffic types, the traffic you really think is important. Is there certain video traffic? Is there certain voice traffic that you want to go differently? And this specific use case is about, we use standard MPLS. We're using MPLS forwarding. But here you see, if you reach an issue on your network, and I show it as congested here, but in fact it doesn't have to be congested. If you have high error rates, if you have high latency, if you don't have the required residual bandwidth, these are not things normally that networks react to, but you now have the capability of extracting this information from the network. And in this case, this operator is using a thing called BGP-LS, BGP link state, extracts the information, it goes up to a higher level application, that actually says there's specific customer traffic or there's a specific application. And what it's using in the downward direction, it's using PSEP capabilities to actually program the path from end to end for a specific class of customer. Now, one thing I have to state with this, the big development here is mostly PSEP itself has allowed the extension from, traffic engineering. If you look at the RFC, there's now been an allowance for putting segment routing in. Very good cooperation between ourselves, Juniper, Alcatel, etc., to allow those extensions, where a lot of the development is happening today is actually in the thing I call CL here, is the classifier. How do you classify what's going into these paths? And that's where a lot of capabilities are coming. Do we use programmability like netconf-yang? Do we use things like BGP attributes? And that's where a lot of development is taking in this environment today. Okay. What other use cases? So when we look at it, a very, very interesting use case comes around this thing called EPE, which is Egress Peer Engineering. And again, what's this overall concept? This overall concept, again, is having a centralized controller. It makes sense. I need to look at my network. I need to look and make a decision what I do at the source. So when you look at it, you say, do I have a specific egress PE? Do I have a specific external interface? Do I have a specific destination I want to reach? And how can I treat it in a different fashion? So this is really taking us away from our common best path type peering model we have today. Again, there's terms here. You can look at the IETF draft to actually look at them. But basically, you have your controller. You have your EP-enabled border router. That's the border router towards your peering partner. And then you have a policy to decide what you actually do with it. I'm not going to go into a lot of detail on, but there actually are 3 different types of labels. It's all down to do with, whether it's a single hop EGP session, a multi-hop, but I'll be using the most simplistic example here, which is where you just have a single connectivity. So, if we actually look at the default behavior, if we look at, what we actually have today, in a standard setup, in a standard setup here, the BGP best path with everything would follow would be A to B to D to go to your destination, 999.32. So what we're actually doing is we're looking to see, okay, going here, we see, I just configure node C, I configure EPE on the eBGP peers, and what it does is, because in this case there's a single connectivity, it just allocates a peer label towards each of those. So 24002, 24003. Again, what it does, it installs these peer SIDs in the actual FIB. So again, if you go in and you just, like any router, you go show MPLS forwarding labels and you put them in, you'll actually see, here we go, here are the labels, here are the interfaces, and this is the next hop. So it's very, very similar, but what you're doing, you're using the labels in a different way. Again, what conceptually happens here then? Conceptually, you then need to gather different information. Now, I'm just doing the bare minimum here of what you can gather. We're working on this with a number of customers where we're actually gathering a lot more. We're using IPFix to get BGP matrix. We're using SLA information to get information further into even the peering partner. We're looking at different capabilities to put on, and I'll give you an example at the end of some of the things we're storing. But the first thing you can do is you extract that information towards the actual controller. The protocols we're looking at today for the EPE signaling, things like BGPLS, as I mentioned already, the link state, or BGPLU, which is the labeled ULECAS, it's about getting that information, getting it to a controller. So you can see here, you get the external topology, you get, very much the peering SIDs, etc. Again, you look here in this case, it will tell them that, 24002, 24003 towards the partners. And the next bit then is, once the controller has this information, he needs to program. He needs to push it down and say, for this actual traffic, and again, in this case, we have an operator in question. They're using BGPLU in this case. It could be PSEP, it could be even netconfig, but in this case, to give you an example, when he uses BGPLU, he says, very much, here's my next hop C, here's the label, 24003, here's the AS path, and here's the BGP policy to say who goes into that path. So again, you can see that all of a sudden we've gone from best path to looking at specific traffic, extracting intelligent information. The information could include latency, bandwidth, etc., making a decision. And what you actually end up with is at the ingress node, you're actually going to push, label stack onto the packets. So in this case here, we're going to push two labels. We're going to push the label to actually get us from A to C, and then we're going to choose a label that will actually take us out on the peer towards E to our destination. So we've decided, based on information we've gathered, that we actually think that's the best path for us to take. Again, if you go in and you look and you actually type in, show Ceph, everyone knows these commands, you'll see that it will show two labels. The first label is the prefix label to get you to C, and the second is the peer node label to actually take you out a specific link. Again, if we look at it, very MPLS-like. What you're doing, you're taking it from the best path, you're taking specific traffic or all traffic, you're putting it onto a path, you're attaching 16,003 to get to C. Once you get to C, you have the 24003. Once it gets there, it sends you out a specific interface, and it sends the payload out towards the peering partner that you have chosen. Again, very, very similar concepts, but being used in a very controlled, very centralized, very controller application way. Just to finish up, we have an example. There's a web OTT we're working very close with that actually uses this example. So the web OTT uses a lot of peering partners. So very interestingly here, they have a number of peering partners. There's a few, there should be peering partners up the top there, the white writing is very hard to see. So when you look at it here, what you basically see is they have a number of peering partners and they have a private network as well. So very, very clearly, what they want to do is they want to choose. They have certain traffic, they have certain users, they have certain customers that they want to choose the best, or may I say maybe the worst connections for them, but this is how they're doing it. So they extract information, very basic at the moment, utilization, response time, packet drop, and they correlate this information in a controller. Again, when a kind of prefix is announced through BGP, so X, Y, and Z are not their routers, they're the peering routers, they actually get pushed back towards the controller. Now, the interesting thing here, they could be pushed back straight towards the controller, or they actually could be learned through their network, which is another very, very interesting concept, because all of a sudden you're maybe saying that you don't need the full internet table on those routers in question there. Not saying I would do it, but that's a possibility. And what they've done then, they enable segment routing in this case. So we have the nodal or the prefix labels, prefixes for each individual router, and then we have a peer SIDS for each individual connection out towards the peers. So again, what are we doing? The controller gathers the information, it analyzes it, and it actually pushes out, and they're actually using netconf to program the caching case. Again, they put the label in position and they've enabled their caches with MPLS. That doesn't mean it has to be done there. We have a customer that will do it in a top of rack, and we have customers that will do the label in position on the routers itself. And what they've done here is they're saying, for this destination, I want to take the best path. The best path in this case is the one with the utilization of 50%. They do not want to risk it with the 93 or the 90. I think the most interesting thing here, this is quite basic use case at the moment, but if you very, very briefly look at how that controller is built, and by the way, that controller could be an external controller, could be a Cisco controller. But from our point of view, it's the interfaces, the information that comes out is key. But I think when you look at this and you look at the information they're storing, the telemetry, how do I gather that information? This decides a lot of things. How do I actually get the topology, the cache topology, the information about the network? But most interestingly is this API. And this API will go out to a third party to make other decisions. So it might be business related. It could be actually customer related that actually decide which path and what performance you're actually going to have in your network. Just as to finish, there are a lot of drafts being co-written by ourselves, a lot of people we work very closely with. I just put them in here. There is also www.segment-routing.net has a lot of good information as well. These are just examples of things we can now do. We are really looking for customers that want to work on unique cases. You know, build your own controllers, use existing controllers. That's where we're going. Thank you very much.
Okay, thank you, Brian, and thank you again, Cisco. Do we have a question or two for Brian at all before coffee?
Just to say, we have a stand out there as well. There are people, if anyone, there's freebies and stuff as well. If you want to come out and talk to us, there's no problem. Yeah.
Neil, and then Job.
My name is Job Snyders.
Hi.
How are you doing in terms of interoperability between you folks and the other vendor that starts with a J?
Well, there's loads of other vendors. So there's more than 2 vendors in the world, I'm afraid. The cooperation in segment routing would have gone very well with ourselves and Alcatel very well originally. So we would have worked. It took a longer time to get Juniper on board. Because you just mentioned them, I'll mention them. But we are actually working quite well now, and you even see the influence of maybe some of the standards they pushed as well. So they would claim that, you know, BGP LU, you know, the label unicast would be more there. Now, we do see a use, and we will be supporting that in certain cases where people want. So I think from an interoperability, and Clarence runs this, I don't know if you know Clarence Fifi very much from Cisco, but Clarence is very, very open. We acknowledge very early on, we cannot go on this alone. You know, if it's only Cisco that supports it, well then, you know, what's the point? Because most networks have Juniper, Alcatel. I would say now the relationship on this front is a lot better than maybe it was a year ago. But definitely with I would say the big 3, if you don't mind me saying that, Alcatel, Juniper and Cisco, we're doing a lot of very, very good developments. You can see there, Juniper are doing developments and some, we're doing some, and a lot of operators. I think some people make a bigger ordeal of BGPLS, BGPLU. I personally don't see the issues. I think a lot of it's operator driven, what they want to use. We will be supporting both protocols. Yes, we'll bring BGPLS first, but very quickly followed by BGPLU. I don't see it as such a big issue as other people do.
Thank you.
Hi, Neil.
Hi, I just wondered if you now got a product for the control aspect of it.
Okay, so that's a good question. Right, so
I'd like to buy it.
we have two different kind of models that are existing at the moment. So, as you know, Neil, we get accused of trying to do closed shop for everything. You know, you either buy it all or nothing. So, to a large degree, we are going down two roads. So what we are doing is, in the case of, and these are OTTs, we will offer the capability of them developing. We're actually co-developing an actual controller with another OTT in relation. They own it, but what we will do is we will do things like the MPLS stack. We will do the kind of interfaces, northbound interfaces. So but that will be their controller. That is not ours. At the same time here, what we are doing at the moment as well is developing our own controller to actually do this. What we were doing is, the plan is in the second half of this year is we have a demo type of it at the moment. In the second half of this year, we hope to have the capability to actually do some of these use cases. Again, it's a gradual thing. We are actually finding that we're being pushed down more the road of do all the intelligence, do the extractor, but a lot of operators want to develop their own controllers or use a controller that they actually have. We are open to the two models. Obviously, I think we are really trying to push our controller as well as such, but I think once we kind of solidify, and going back to the earlier question, on the protocols people want to use, for instance, if it's netconf yang and very heavily, we will integrate TLF into it to get the scale of TLF. If people are saying they want it all BGP, we may look at other components to put into it. They're the sort of things that are deciding at the moment.
I think it's a great piece of work. We're very much in favour of this because we have all sorts of kind of failure scenarios that this helps us with on legacy networks. So we're pushing this really aggressively, and I think the work you guys, ALU and now Juniper, are doing is great. So thanks for that.
No, and thanks a million. I mean, without the operators, this is absolutely key.
We got one more question, but can we keep it quick because we're eating into coffee time now?
Yep. Julian Lucek from Juniper Networks. On the subject of the...
I was thinking when I said it, I think I was nice, in all fairness. I was nice.
On the subject of interop, in fact, a large customer of ours did a three-way interop test last August. So this was Juniper, Cisco, ALU. Now the tests, aren't in the public domain, but it's sort of, I guess, an open secret in the industry that they occurred. And they went well. Everyone had bugs, and it was very useful to help iron out bugs. So that sort of interop test is extremely useful. On the subject of what's available, I mean, we introduced one aspect of segment routing, or Spring as it's called, in our codes way back in UKNOF30 13.3 for the particular use case of ultra-fast PE protection. And the last point is
I think you should pay for the sponsorship the next time you get the few minutes to come up.
Can you get to the question?
It's just a few pounds you can pay to be here.
I mean, the final point is if anyone wants to test our codes, please come and talk to me, and we can get that to you for your own testing.
Thanks. Thanks, guys. Thanks for your time.
Okay, thank you.